Assalamualaikum and hello everyone. Today I'm going to explain about one of the key topic in technical math 2, which is a differentiation, especially the rate of change and why it matters in technical and engineering field. Differentiation is the process of finding the rate at which one quantity changes with respect to another. This is written as dy dx, where y is a dependent variable and x is an independent variable. For example, if you want to know how fast temperature is rising or how quickly a chemical concentration is dropping, we use this concept. And in simple terms, the rate of change tells us how fast something is increasing or decreasing. In engineering field, we use this all the time. We calculate how pressure, temperature or flow rate change in system. In physics, we use it to study velocity and acceleration. And in chemical engineering, our field will become even more important. We apply differentiation to monitor reaction rate, control heat transfer, and manage fluid flow in pipe or reactor. It also helps us make decisions about system efficiency, safety limit, and overall performance. So, why should we care about this as a student? Because understanding and applying the concept of rate change gives us the analytic skill we need to solve a real-world technical problem. It turns abstract math into something practical, something we use in lab, project, and eventually in our career. To sum up, differentiation isn't just another math topic. It's a powerful tool that helps us understand how systems behave and change. And for us, a future chemical engineer, it's an essential part of solving the challenges we face in the industry. Thank you.
Hello, my name is Alice, and today I'm going to show you how to solve a calculus problem involving the rate of oil throughout the pipeline. So for the given function, f of t equals 20e to the power of negative 0.3t, where f of t means the flow of oil in barrels per hour, and t is the time in hours. So our task is to determine the rate at which the flow rate is decreasing after 2 hours. So step 1 is finding derivative. To find how fast the flow rate is decreasing, we will need to find derivative of f of t with respect to t. So with this, we will have to use the chain rule. Then we differentiate the function. And the derivative of f of t equals 20 times negative 0.3 times e to the power of negative 0.3t. Then we'll have to simplify f prime of t equals negative 6e to the power of negative 0.3t. And for step 2, we will have to substitute t equals 2 to find the rate at that time. f prime of 2 equals negative 6e to the power of negative 0.3 times 2. We will have to simplify the exponent. That's negative 6e to the power of negative 0.6. And next, we have to use a calculator. E to the power of negative 0.6 is approximately 0.5488. So we will get f prime of 2 equals negative 6 times 0.5488, which gives us f prime of 2 is approximately negative 3.29. And the final answer, the rate at which the flow rate is decreasing after 2 hours is approximately negative 3.29 barrels per hour squared, which emphasizes the negative sign shows that the flow rate is decreasing. And that's how we determine the rate of decrease of the oil flow throughout the pipeline after 2 hours. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Natasha Dita. So now I want to present about problem 2. The question is, calculate the rate at which the cross-sectional area of the pipe is increasing when its diameter is 50 cm. Discuss the implication of this expression on the efficiency of the heat exchanger system. So, the question given us, the diameter is 50 cm. And also, the question gave dD over dt is 0.01 cm. So, as we all know that area of second formula is pi r squared, or we can write as pi d squared over 4. So, from the area of circle, we can find the differentiation area. So, the A over dt is pi d over 2. So, from the question, we know that they want us to find dA over dt. The formula is dA over dd multiplied with dd over dt. So, from the answer that we find out above, we know that dA over dd is pi d over 2. We multiply with 0.01, which is dd over dt. So d we can replace as a 50 from the question. So we calculate the answer is 1 over 4 pi cm square over hour, or we can write as 0.7854 cm square over hour.
Assalamualaikum and hi, my name is Nur Faika Dayana binti Haris, and for my part, I would like to present the Fila table for two applied differentiation problems involving rate of change. So, what is Fila table? Fila table stands for F is facts, I ideas, L is for learning issues, and A is for action plan. So, let's go through each part clearly. For question 1, facts is the flow rate of oil is given by the function ft equals to 20e the power of negative 0.03 t, where time is in hours. We are asked to find how fast the flow rate is decreasing after 2 hours. So the ideas for this question is, since we are looking for how fast the flow rate is changing, we need to differentiate the function to get the rate of change. Then we substitute the t equals to 2 into derivative to get the exact value. Next is the learning issue. We need to know how to differentiate an exponential function, especially using the chain rule. Also, we must understand the meaning of negative derivative. It means that the flow is decreasing. So for the action plan, first we need to differentiate ft to get the f prime t equals to negative 0.6 e power of negative 0.03 t. Then we substitute the t equals to 2 into the derivative. We get the decreasing rate as approximately negative 0.5651 barrels per hour squared. So the negative sign confirms that the flow rate is indeed decreasing. Next is for question 2. So for the facts for this question is, the pipe's diameter is increasing at rate of 0.01 cm per hour due to heat. The current diameter is 50 cm. The cross-sectional area is circular and given by A equals to pi d squared over 4. The ideas for this question is, since the diameter is changing, the area will also change. We can calculate to find how fast the area is increasing. Again, we use the same rule, which is chain rule. For the learning issue, we need to apply the chain rule correctly in the area formula. Next, we also need to understand how changes in pipe size can impact system efficiency. like heat transfer or fluid pressure. So lastly, for the action plan for question 2, we need to differentiate the area formula to get dA over dt. So to get that, we need to times pi d over 2 times dd over dt. So next, we need to substitute dd with 50 and dd over dt with 0.01. So the rate of increase of area is about 0.7854 cm squared per hour. So we discussed it, while some expansion can improve flow, too much can lead to mechanical stress or inefficiencies in heat exchange.
My name is Elena binti Emputin, and I'm going to explain my part, which is the discussion and conclusion. So for the discussion, the study has provided insight into the application of differentiation, which is the rate of change, where students have gained the ability to understand and analyze the change in one quantity with respect to the change in the other quantity. So for example, assume we have a function of y equals to fx, and then the derivative dy over dx can be interpreted as the rate of change of y with respect to x. So as a result, problem 1 can be solved using the chain rule, which is dA over dt equals to dA over dr times dr over dt, and then the answer would be negative 3.29 barrels per hour squared. And as for problem 2, we can use the same method, which is the chain, using the chain rule to solve it, and the answer would be 1 over 4 cm squared over h, or 0.7854 cm squared over h in decimal number. And as for conclusion, there are many inputs that we can obtain by studying the application of differentiation, rate of change, where we could also apply it in the real-world setting. So, for example, we can use differentiation to solve problems in physics or engineering, where the derivative is more than just a mathematical operation, but can also help us to analyze the behavior of dynamic systems, and it also gives us the optimal solution. And with that, understanding and applying this mathematical operation in our everyday situations has helped us to make informed choices, hence improve the overall quality of our work. So through this topic, it has gives us the fundamental skills to solve problems across various fields such as the engineering field, as well as strengthen our abstract calculus skills and problem-solving skills. But what is that skills for? That skills can contribute in the future needs of our country as well as for ourselves. That's all from me. Thank you.